Welcome back. So now is the time that we are going to take whatever knowledge we had taken in the previous modules and apply it in practice so that we can solve numericals. They aren't that tough. Listen to me carefully. I'm 100% sure you all will be able to grasp the concept very easily. Let's begin. Now, what is the first example? Let's have a look. It says, and I quote, how many molecules are present in 66 grams of carbon dioxide? Now understand, it has already been given to me that the atomic mass of carbon is 12 and the atomic mass of oxygen is 16. You don't need to remember this. This is something which will be given in the sum. Great, no problems over here at all. What is going to be my first step? My first step, very logical. Let's have a look. We need to calculate the molecular formula of carbon dioxide, which is obviously CO2. Apart from that, when we calculate the molecular formula, that ultimately has to translate into the molecular mass. Now think about this. What is the mass of one atom of carbon? 12. How many carbon atoms are there? 1. So 12 into 1. In a similar manner, how many atoms of oxygen are there? 2. And what is the mass of a single atom of oxygen? 16. So 16 into 2. 12 into 1 is 12. 16 into 2, 32. 12 plus 32 gives me a gross total of 44. What is that? That is the molecular mass of carbon dioxide. Let's continue. Now we need to calculate the number of moles of carbon dioxide. We have a formula. It's very easy. Mass of carbon dioxide which is present in grams, which is given to you in the sum, is the value in the numerator. Molecular mass of carbon dioxide is the one that you just calculated with me, that is the denominator. So 66 is the value which is the mass of carbon dioxide given in grams in the numerator in the sum, which was already supplied to you. 44 is the molecular mass of carbon dioxide that you and I calculated right now together. 66 divided by 44, very easy calculation, gives me 1.5 moles, which means that 66 grams of carbon dioxide is actually nothing but 1.5 moles of carbon dioxide. Now, does the sum end here? No. You need to tell me how many number of molecules are there in that 1.5 moles of carbon dioxide. Let's have a look. We know as a matter of fact that if you take 1 mole of any substance, 1 mole of carbon dioxide for example, it will contain 6.022 into 10 raised to 23 molecules of carbon dioxide. But do I have 1 mole? No, I have 1.5 moles. So if 1 mole contains Avogadro's number of molecules, 1.5 will contain how much? Perfect. That is going to be 1.5 into Avogadro's number of molecules. So 1.5 into 6.022 into 10 raised to 23. Now what do you need to do? Do not touch that 10 raised to 23 at all. It's a singular value. Let it be like that. Multiply 1.5 and 6.022. When you do that, the perfect answer comes as 9.033 into 10 raised to 23 molecules of carbon dioxide, and that, my dear child, is the answer that we were wanting in the first place. We've got it. Let's give it in the form of a statement to complete the entire sum. Have a look. 66 grams of carbon dioxide will contain 9.033 into 10 raised to 23 molecules of carbon dioxide. Easy, wasn't it? Now if you've understood that, let's apply the knowledge to a few more sums. Let's become more perfect at this, sum by sum. Have a look. Okay, so and 66 grams of carbon dioxide contains 9.033 into 10 raised to 23 molecules of carbon dioxide. Numerical number 2. Okay, example. How many molecules are present in 80 grams of sulfuric acid? Atomic masses of all the elements are given to you. Whatever is there in sulfuric acid, that is. Hydrogen is 1, sulfur is 32, O is 16. It is already given in the sum. You don't have to remember these values. Have a look. Okay, solution. What is the molecular formula for sulfuric acid? We know that. Molecular formula for sulfuric acid is going to be H2SO4. And when you get the molecular formula of sulfuric acid, you will calculate the molecular mass. What is the mass of one atom of hydrogen? 1. How many are there? 2. So 1 into 2. What is the mass of a single atom of sulfur? 32. How many are there? 1. So 32 into 1. For oxygen, altogether different ball game. 16 is the mass of a single atom of oxygen. We have 4 of those. 16 into 4. So 2 into 1 is 2. 32 into 1, 32. 16 into 4, 64. 64 plus 32 is 96, 96 plus 2 is 98. That is the molecular mass of sulfuric acid. Great, isn't it? So, how do we calculate the number of moles? We know number of moles has a very, very simple formula. The number of moles of sulfuric acid are given as mass of that particular substance upon the molecular mass of that particular substance. Where is the mass of the substance given? It is given in the sum. How much is it? 80. Let's directly substitute that in the numerator. What is the molecular mass we calculated? 98. Let's put that in the denominator. 80 by 98, that gives me 0.82 moles of sulfuric acid are present in 80 grams of sulfuric acid. Is the sum over yet? One more step to go. We found out the number of moles, we need the number of molecules, but we have a statement for that as well. 1 mole of any substance, 1 mole of sulfuric acid contains 6.022 into 10 raised to 23 molecules of sulfuric acid. Do we have 1 mole? No, we have a slightly lesser quantity. We have 0.82 moles. So, what are we going to do? Take that 0.82 multiplied by Avogadro's number, get your final answer. Come on, let's do it together. So, 0.82 moles of sulfuric acid contains 0.82 into 6.022 into 10 raised to 23 molecules. What part of this number did I not tell you to touch? Correct. We don't have to touch 10 raised to 23. So, what do? Just multiply 0.82 and 6.022. Multiply them together, you get 4.938 into 10 raised to 23 molecules of sulfuric acid. As simple as that. I hope your understanding is getting better. I'm going to challenge you a little bit more. Let's increase the level a little bit and see if we can still grasp the concept. Have a look. So, 80 grams of sulfuric acid, which was given as a sum, contains 4.938 into 10 raised to 23 molecules of sulfuric acid. Okay. Numerical number 3. If 0.2 moles of calcium carbonate is required, they are asking us, we need 0.2 moles of calcium carbonate. How many grams of calcium carbonate should we take? It's a relatively different sum, but way easier. Have a look. Atomic masses are given, as always. You don't have to remember them, they'll give it to you. Atomic mass of calcium is 40, for carbon 12, for oxygen 16. What do we have to do first? We need to give the formula for calcium carbonate. What is the formula for calcium carbonate? Very easy, we know it is CaCO3. And once you have that, what are we supposed to do? We need the number of moles of calcium carbonate. How much is needed? 0.2 moles. Yes or no? So, we calculate that mass in grams of 0.2 moles of calcium carbonate. That is what we want. Okay, solution. Molecular mass of CaCO3 is something that we need to calculate. I presume that the number is going to astonish you. You'll like it. Why? Because the calculations with respect to that is very, very easy. Let's have a look. Calcium, we have one atom. What is the mass of that one atom? 40 into 1, because we have a single atom. Carbon is 12. How many of those? 1. So, 40 into 1 and 12 into 1. But oxygen, different ball game altogether. 16 is the weight of one atom of oxygen. We have 3, so 16 into 3, right? So, have a look. Atomic mass of calcium into 1, atomic mass of carbon into 1, but atomic mass of oxygen into 3. Substitute the values, 40 into 1 plus 12 into 1 plus 16 into 3. Magical number appearing. Why do I say that? It comes as a perfect round figure 100, which means the calculations from now on are going to be so simple, right? Okay. Now, when I say that the molecular mass of calcium carbonate is 100, that is for 1 mole of calcium carbonate. Do I need 1 mole of calcium carbonate? No. They have asked me to calculate the grams in 0.2 moles of calcium carbonate. So, let's put it up. Number of moles for calcium carbonate, same formula. Mass of calcium carbonate in grams, this time not given in the sum. This time we need to calculate it upon the molecular mass of calcium carbonate. Now, you have 3 values. You have 1, 2, 3. Out of those 3, 2 are always given. Let's substitute. So, we want 0.2 moles. That's what we substituted here. 100. From where did we get it? You and I just did it together. Correct? And mass of calcium carbonate is something that you need to calculate. Take this 100, put it over there, 0.2 into 100. I told you, you'll love the calculation. 20 grams of calcium carbonate is needed for making 0.2 moles of calcium carbonate. That's my answer, isn't it? Beautiful. So the mass of 0.2 moles of calcium carbonate is 20 grams of calcium carbonate. That's my final answer. That's what you and I were working so hard for, and we've got it. Okay. Final numerical. One last time. Let's have a look. Okay. Last one. If 0.4 moles of sodium sulfate is required, how many grams of sodium sulfate should be taken? Given NaS23, SS32, OS16 at our service. They've given it to you. You just need to utilize them. And if you realize numerical number 4 is very, very similar to numerical number 3. So let's follow into the footsteps. What will we do? I need the formula first of all. Sodium sulfate is given by the formula Na2SO4. Great. And how many moles do I need? I need 0.4 moles of Na2SO4. That's the one that I require. Correct? So first, let us find out the mass in grams for 0.4 moles. That is what we need. Find out the molecular mass. Okay, think. Sodium, 23 is the mass of one atom. I have 2. 23 into 2. Sulfur, I have a single atom. But what is the mass of that single atom? 32. So 32 into 1. Oxygen, always a problem, yeah. Have a look. Oxygen, one atom is 16. How many do we have? 4. So 16 into 4. Let's put it up together. So there we have it. 23 into 2, 32 into 1, 16 into 4. Correct? Okay. That gives me 46 plus 32 plus 64. What's that? 142. We don't really like that number a lot. Maybe it's going to difficult our calculations. It's fine. We'll still manage. Let's scrape through together. Okay. According to the formula, we know mass of a particular substance upon molecular mass of that particular substance gives you the number of moles. 1, 2, 3 values. Out of 3, 2 will always be given. What is the one that is missing? The one that we need to calculate is mass of that particular substance. But we know number of moles already. So number of moles is 0.4. Mass of the substance we need to calculate. 142, you and I just calculated together. What do we need to do? 142 needs to be shifted on that particular side. 142 into 0.4, right? So when you do that, 142 into 0.4 gives you the final answer that you were waiting for, isn't it? That is going to be 56.8 grams. That's the answer I was waiting for. So if you need 0.4 moles of sodium sulfate, you need 56.8 grams of sodium sulfate to be precise. Thank you.